Webcast in partnership with Prysmian. Today we're going to look at fibre to the home, the evolution of density and last mile solutions, with a focus on helping FTTH network operators overcome some of today's biggest challenges. I'm Keely and I'll be your moderator today. Welcome. And I'm delighted to be joined by two expert speakers. We have Ian Griffiths, Global R&D VP for the Prysmian Digital Solutions Division, and Chris Roberts, Global Product Development Manager, Connectivity at Prysmian Group. In terms of the format, each of them will present for 15-20 minutes, and then we'll have a short Q&A at the end. Do feel free to answer your questions as they occur to you, and we'll read them out at the end. You don't need to wait. So without further ado, I shall hand over to Ian. Ian, the floor's yours.
Hello and welcome. My name is Ian Griffiths and I'm the R&D Vice President for Prysmian Digital Solutions Division. Today I'm going to give a brief overview of the Sirocco HD and Sirocco Extreme cable ranges. The presentation should last around 15 to 20 minutes and is designed as just a high-level overview of the current cable ranges, some new developments and some of the sustainability benefits. More detailed information such as brochures, data sheets, etc. can be requested via the platform and we'll send those to you later. During the presentation, you'll be able to ask questions using the platform and we'll do our best to answer all of those by the end of the session. But if that's not possible, we will come back to you using your contact details. Thank you for your attendance and I'll now start the presentation. Microduct cables are a popular choice for FTTH, backbone and data center interconnect networks due to their compact size and ease of deployment. They usually have a loose tube construction and are blown as and when required into microducts, usually with internal diameters ranging from 3.5 millimeters up to 14 millimeters. Typical blowing distance required are in excess of 2 kilometers as standard. Increased demand has put strain on the current network infrastructure, and customers are demanding to maximize their existing network capacity, fitting as many fibers as possible into a duct. To achieve this, there has been a strong drive for cable manufacturers to continually look at ways to reduce the diameter of these cables. At Prysmian, our innovative R&D teams have been working over the last few years to design a new range of next generation microduct cables, with the simple target of being able to offer the lowest diameters and the highest fiber densities available on the market. We have achieved this with our Sirocco HD and Sirocco Extreme cables. These cables are not only the best in class in terms of size, but also in overall performance. This has been achievable due to a number of key enablers that we have in our portfolio, and we will examine these in the next few slides. The first key enabler is the fiber diameter itself. The use of smaller diameter fibers in these cables ensures a reduction in loose tube diameter, which translates to an excellent saving on the completed cable. Prysmian were the first to introduce a commercially available 200 micron fiber back in 2009. This provided a 30% reduction in area. Then in 2019, we were the first to launch a commercially available 180 micron fiber, which increased its area reduction to 50%. It's also important to mention that both our 200 micron and 180 micron fibers are true diameters. Others claim to have 180 or 190 micron fibers, but this is pure marketing. When you look closely, these stated dimensions are only for the natural fiber and are not for the final dimension after the fiber has been colored. This is because they have to apply an additional 10 micron ink coating to their fiber for the color identification. Prysmian do not need to do this as we have our unique color lock technology, where our secondary coating already contains a color in pigments. So when we say 200 and 180, we mean it as a total, including the color. Another point to mention here is that there is no issue in splicing 200 micron or 180 micron fibers to existing 250 micron. There seems to have been some confusion on the market about this, but We have to remember that the core and the cladding diameter are the same at 125 microns. It's only the coating thickness that changes, and of course this coating is removed before splicing. Next, we have the fibre itself. Here the use of bending sensitive fibres is key. When you pack fibres together in a tube, microbending performance becomes important. The lateral forces of the fibres touching against each other and the surface of the tube induces microbending. This is especially evident at low temperatures, but it can be significantly reduced using bending sensitive fibres G657A1 and G657A2. The need of an A2 over an A1 often depends on a number of factors, such as the cable structure itself and the temperature requirements of the customer. In the case of the 180 micron fibre, only G657A2 can be used due to the reduced fibre coating thickness. It's not only the quality of the glass itself, however, but also the quality of the fibre coating is crucial. Prysmian have a very strong fibre coating, which has a very good microbending performance. We see this when we test third-party fibres in our cables, as we see a drop-off in performance, especially at low temperature. The diagram here can show the effect on the use of the different type of bending sensitive fibre on the overall diameter of the cable. In this example of the 288 fibre cable is 8.5 millimeters using standard G652D. This can be reduced by 1 millimeter with the use of A1 or A2 bending sensitive fibre, and almost a further millimeter by using the 180 BBXS G657A2 fibre. Finally, we can consider the use of new raw materials and the number of fibres per tube. Here, Prysmian developed with our material partner a new grade of PBT that enables us to draw thinner wall loose tubes. Usually a loose tube has a thickness of around 0.2 millimeters, but with this new grade we can draw down to as low as 0.05 millimeters. Also, putting 24 fibres into a tube is much more space efficient than when using 12. When we combine the new thinner wall tubes and the use of 24 fibres per tube, we call these pico tubes. You can see by the picture the direction of tubes dimensionally over the last few decades. And now with our new pico tubes, we obtain another step change of approximately 0.3 millimeters for our 200 micron tubes and 0.4 millimeters for our 180 micron tubes. When we combine all of these enablers together, we developed two new ranges of cable. Our Sirocco HD that uses 200 micron fibre with our new pico tube technology, and the Sirocco Extreme that uses the 180 micron fibre with our new pico tube technology. Both of these ranges are available with fibre counts from 36 to 864 fibres. When we look closer at the complete cable ranges, you can see that for each fibre count, a significant decrease in diameter is achieved between the standard cable and the Sirocco HD. And then a further step change is achieved from Sirocco HD to Sirocco Extreme. This can also be viewed as an increase in the fibre density per square millimetre of each cable. If we consider the average fibre density over the whole cable range, you can see that a 23% benefit is achieved for the Sirocco HD and a 54% benefit for the Sirocco Extreme versus our standard microduct cable. If we went back just a handful of years, a cable with a fibre density per square millimetre of 3 was deemed as dense. But here we're talking about fibre densities into double digits. The Sirocco Extreme 864 fibre cable is new. This was launched in January 2024. You can see here in the table that this has an incredible 11.5 fibres per square millimetre, making this now the densest optical fibre cable on the market today. The previous densest fibre cable on the market was the 576 Sirocco Extreme. An additional benefit of reduction in cable diameter is that we use less raw materials during manufacture. and this provides a reduction in CO2 generated in the making of the cable in the region of 20% for the Sirocco HD and 30% for the Sirocco Extreme. More importantly, though, is the view by duct size, as this, at the end of the day, is what really matters to the end customer. This table shows how the fibre count installable into the duct can be increased depending on the solution used. So if we look at an example, such as the 10mm internal diameter duct, you can see that previously we can install up to 288 fibres. Now this is increased up to 432 fibres using Sirocco HD and 576 fibres using Sirocco Extreme. Other examples, if we look at the 12mm ID duct, for the first time you now see the possibility of installing up to 864 fibres into this duct. And this is only possible due to the 180 micron Sirocco Extreme cable. Likewise, for the 14mm ID duct, you see again 864 also possible with the Sirocco HD now. And when we look at some of the smaller ducts there with 3.5 and 4mm internal diameters, we can see that the 36 and 48 fibre Sirocco are now possible to install into those ducts. I'll come on to that in the next slides because these are new cables that are due to be launched pretty much now in 2024. Next, we can look at some of the new developments for 2024. With the main cable range completed up to 864 fibres, we now set our sights on extending the range down for the smaller microducts with internal diameters from 3.5mm to 5mm. The first new product launched in June this year is the Sirocco Unitube. This is a single tube Sirocco cable with fibre counts from 2 up to 24 fibres. It's primarily targeted to be installed into 4mm internal diameter ducts, which are very popular in North Europe. The Unitube is also targeted to reach blow-in distances in excess of 1 km and is supplied in a very cost-effective package. It's a central tube construction that uses 250 micron G657A1 fibre as standard. The second new development is for 36 and 48 fibre versions of the Sirocco HD and Sirocco Extreme cables, which we touched on a little bit earlier. These cables are loose tube construction with 6 fibres in each tube. The Sirocco HD 36 fibre is targeted for a 4mm internal diameter duct and the 48 fibre version for a 5mm internal diameter duct. For the 36 fibre Sirocco Extreme cable, there is still some development work in progress. This is to determine if it can be used in a 3.5mm ID duct, but initial trials have indicated it should blow in excess of 500 meters. Likewise for the 48 fibre Sirocco Extreme in a 4mm ID duct. Both will exceed the 1 km in the ducts they were originally targeted for. So the 36 fibre into a 4mm internal diameter duct and the 48 fibre into a 5mm internal diameter duct. For both cases, the Sirocco Extreme cables are only possible using our Benbright XS G657A2 fibre. All of the Sirocco HD and Sirocco Extreme solutions that we've seen so far are ideal for use in our Corona overblow solution. The Corona overblow solution enables the installation of a high-density cable into a duct that is already occupied with a legacy cable. The advantage of this solution is based on the cost of installing new routes, which is usually prohibitive and involves digging. It's not just the extremely high cost of digging that is a concern, but also the time that you lose beforehand in obtaining licenses and permissions to dig. And even after starting, digging is a very slow process and 100 meters per day is considered fast. With overblow, there's no need for licenses or digging, and the cables can be installed at a speed of 40 meters per minute. So huge cost savings can be made, as well as large environmental benefits. The sort of routes that are typically used for overblow are shorter than the sort of 2-kilometer standard blow for these type of cables. But they're ideal for situations like network extensions and diversions. It's possible to overblow cables of up to 864 fibers into the legacy ducts, and also possible to install more than one overblow cable depending on the situation that you come across. This slide shows a simple table that can be used to determine the fiber count that is possible to install. Quite simply, you start with the internal diameter of the duct size and the size of the legacy cable already installed. Then you need to allow 1 millimeter radial clearance, and you calculate the free space that's available. This will tell you the maximum diameter of the cable that you can install. This table really does that for you, and also informs you of the maximum fiber count that can be installed using Sirocco HD or Sirocco Extreme. As you can see in the table, there's up to 864 fibers is possible, depending on the situation. Earlier, we touched briefly on the sustainability benefits of Sirocco HD and Sirocco Extreme cables in terms of the CO2 that was generated during the manufacturing process. But it's important to highlight that these reduced diameters also provide additional sustainability benefits. For example, when we supply a full solution and we also include recycled ducts, the overall CO2 reduction for the total solution can be increased to around 40%. There is also the benefit of being able to fit more cable on a drum, resulting in transport reductions. In a recent installation in the Netherlands, we calculated this saving as around 6 trucks for each 10,000 homes installed. Cutting losses can also be improved, and an additional benefit is soil removal and reclamation. This can be quite an expensive process, but using smaller ducts and smaller cables can mean the removal of less soil and less cost of cleaning that soil. But of course, the biggest saving of all is to be able to avoid digging new routes due to the benefit of being able to install more fibre into your existing duct infrastructure. Finally, as we're so sure that our fibres and our raw materials are of the highest quality, we recently conducted long-term testing, which took the whole 2023 to complete. This testing involved aging in both dry and wet conditions, and the purpose of it was to simulate a lifetime of more than 50 years. On completion of this testing, the data demonstrates that the Sirocco cable's optical fibre attenuation, the cable performance and the material properties remain effectively unchanged and can easily meet industry standards for newly manufactured cables. With the completion of this testing, it's now possible for operators to calculate the life cycle analysis of their networks over a much longer period of time, of more than 50 years. And that is the end of the presentation. Thank you all for listening. If you require any further information, such as data sheets, pricing, test reports, etc., please contact your local Prysmian office. Alternatively, you can use the platform here to submit any questions or any inquiries, and we'll get back to you as soon as possible. Thank you.
Thank you, Ian. Before we move into the main focus of the connectivity presentation, which is more focused around last mile solutions, I'll show you a couple of closures that we've developed to support the Sirocco cables that Ian has just presented to you. With the introduction of Sirocco cables, we developed one new closure to ensure we have the full solution, and also a smaller closure that's more in line with the compactness of the Sirocco cables. So Sirocco closure is supplied with 36 splice trays, giving a maximum capacity of 432 fibres. The closure is largely based around our more popular CMJ and MMJ closures, which a lot of you should be familiar with. This closure is using the same base, but it's 500 millimeters long. So it's actually the same length as our LMJ short cap, which I'm actually going to cover on the next slide. This closure has 4 round ports and 1 oval port. A range of closures all use the same round port for the mechanical cable sealing system. So that means no matter which closure you're working on, the common cable entry can be used. Our circular ports can house between 1 and 8 cables depending on the diameter. The oval port in this closure, the SMJ, can take a diameter up to 21 millimeters and can be used for loop-through applications. The splice trays in the closure hinge upwards, allowing easy access to the tray below, and they remain fully supported in that upwards position. The large loop storage area behind the trays has ample space to secure unused or loop-through cable elements from your Sirocco cable. Below the splice trays, we've got an entry manifold which has the ability to house 2 splitters with a dimension of 4 millimeters by 7 millimeters, so that's typically your up to 32-way splitters. Alternatively, you could choose to fit up to 4 2-way, 4-way, or 8-way splitters. So there's quite a bit of flexibility in that manifold. You can also use that manifold as a crossover point between the left and right hand side of the tray stacks, because the trays supplied in this closure don't offer that feature on the trays themselves. But on every splice tray, we do have the ability to house an 8-way splitter and 12 splices. The closure is supplied with a pressure relief valve as standard. So for safety, when using blown fibre ducts, you've got the reassurance that the valve is there. So if a duct is pressurised by accident, that closure isn't fully pressurised, that pressure is going to be allowed to escape. To support the installation, there's a full range of accessories, including pole, wall and mobile mounting kits available. And we have a tube anchor bracket, which can be fitted to the bottom of the closure. The tube anchor bracket allows additional retention when using blown fibre ducts. If you're using a cable with a higher fibre count than 432, then you would need to move up to our LMJ range and the short cap, which is the smallest in the LMJ range. It's the same height actually as the SMJ, it's just a bigger diameter. The LMJ has a wide range of splice tray options, giving the user a lot more flexibility. So for instance, if you're using a cable with 24 elements, then you could consider using a 24 fibre splice tray. And that would actually give you a maximum capacity of up to 1,152 fibres, which is a lot of fibre. The LMJ is complete with 10 round entry ports, and as I mentioned on the previous slide, we use that common sealing system across all our closures. So it's the same entry kit whether you're using a CMJ, MMJ, SMJ, or indeed the LMJ. And it also has 1 oval port. The oval port on here is different to the SMJ. It's slightly larger. But as with the SMJ, obviously the round ports can house up to 8 cables. At the top of the closure, there is a crossover manifold. So this is allowing fibres to pass from side A to side B as the closure. And on the base, actually, we have it moulded side A, side B. So even if you're doing your network diagrams, you can specify tray 3 on side A, and it's easy for the engineers to spot it. So the manifold at the top allows easy access from side A to side B of the closure. But it also has the ability to house up to 4 32-way splitters. So again, nice to put your splitters there at the top of the closure. The splice trays here, we have, as I said earlier, we have a wide range, but the majority of those can also house a splitter and at least 12 splices on every tray. There's also the ability to cross fibres at the bottom of the tray stack. So I just discussed the crossover point at the top. We can actually cross them over at the bottom as well to get from side A to side B of the closure. So this means you haven't got to get all your fibre up the channel to the top to cross over. You can decide whether you cross at the top or the bottom. On both sides of the closure, there's an entry manifold, and here we can either store excess fibre, or we can use it to switch from the left or the right hand side of the routing channels up the trays. So it's got sort of a few features really, the two manifolds. We have the loop storage area on this closure. On the SMJ, I described it as behind the tray stack. Here it's in between the two tray stacks, and there's two options for the storage. There's the quite common coil it around, maybe put a cable tie on it and slot it between the trays, or we actually have a loop storage tray which hinges in and out. This is really good if you are needing to get access to that loop regularly. It's a lot more controlled. It's better managed as the fibres come in and out. A range of accessories as well for this closure, including a support tool, so you can get this closure into sort of a workbench and secure it to a support part that would help the engineers while working on it. It secures it. But we also have, for long-term fixing, we have the internal motor arm on this closure. So the arm comes through the base and actually sits inside the cap. So it's reducing the amount of space it takes in the pit. And the closure is rated to IP68, so it's very suitable for your underground applications. We are now going to move into the main section of the presentation, the last mile connections. With the time available, I can't cover everything we've got, but I'm going to cover two closures for two products that go at the end of the access network. And I've got a couple of options on drop cables, which I'll show you, which are obviously used to get from that access point to the customer termination or the outside of the property. And then I've got a few products that are there on the outside of the property, which we can go through. We move. We'll start with the last point of the access network and the final closure. I've been talking about closures for sort of 5 or 6 minutes already. But this is the pre-code closure, so it's again based around the SMJ range, or the CMJ, MMJ, SMJ range. So it's using the same base as the SMJ and the same splice trays. We've got two versions available, and as we increase the size, we can actually increase the number of customer drops. So it's the MMJ, which is the largest. If you know our MMJ splice only closure, it's the same construction as that, but we've removed some splice trays and added up to 48 LC connector positions. The MMJ is 390 millimeters long, while the CMJ is 305 millimeters long. So the CMJ is a little bit smaller and can be actually mounted at the lower position on a pole as well. As I said, they're based around our standard closures, so we have a full range of accessories available for these closures. Again, the cable entry system for the round ports is common across them all, so this again is helping with the stock management that you need to hold. It's probably worth mentioning actually at this point that all our closures and wall boxes that we're showing today are manufactured here in the UK. They're all tested to IEC standards, particularly 61300 and 60068, and that's to make sure they're suitable for use in your network. Typically our base and caps are made from glass reinforced plastic to ensure they're nice and robust to withstand the toughest storage conditions. And then back to the pre-code closure itself, it's suitable obviously for aerial or underground applications. It's IP68 rating. In fact, it's up to 7 meters. This has been tested too, so it's a really solid seal on that one. And the closure has the ability to house a range of pre-connectorized splitters. So what that means is when you install that closure, you can bring your cable in, and you've only got to make maybe one splice, and you've got potentially 8 customers, 16 customers all ready to go. You just need to plug those drop cables in. So we're going to move away from closures. We're going to move to the aerial Castlelink closure, and this is an aerial mounted product with an IP rating of IP55. It's sleek in its design, it's compact, it can house up to 32 LC drops using a 3mm drop cable. The inside of the box has been designed in such a way that all the parts are tethered together. So this is a great advantage when your engineers are working at height on the pole. They haven't got to worry about unscrewing bits and pieces. They can just open and close the parts quite easily by loosening clips. You can simply hinge the patch panel and the anchoring system away from that loop storage and large splice area. The AC/DC can be mounted directly to a wall. It can be mounted directly to a pole, or it can be mounted to an excess storage bracket, which then can be fitted to a wall or a pole. The product is compatible with 5mm drops or 3mm drops. So when we move from the last point in the access network to the customer, we have to have a drop cable. We're fortunate at Prysmian, we have a vast range of these cables. I'm going to cover 4 in total today. The first one I'm going to cover is the 3mm drop. This is compatible with the 2 products I've previously presented. All the products I've presented so far, this is compatible with. But with this 3mm diameter, this drop cable is great for use in highly populated areas. We can maximize the number of drops exiting the network access point. We can supply this drop cable in a wide range of lengths and connector options. With our standard solution, we slide on a simple cardboard ring, as you can see in the image, but we can easily make that customized to suit your dispensing equipment. We can also add pull-in eye solutions to the ends of these cables if needed. The next up is our UDS1. This is a dual sheath cable with a diameter of 5mm. The beauty of this cable is that inside that 5mm black external sheath is a CCA rated white internal cable. We have 2 rip cords that are left exposed that allow quick and easy access to that internal cable. So with this cable you can enter the building, route it round the inside of the property, and then strip back that black sheath and leaving just that 3mm white sheath around the inside of the property, and terminate that sort of black, or anchor that black sheath outside in the termination point. As with the 3mm cable, we've got this in a whole host of lengths with various connectors, and of course again pull-in eyes can be, or pull-in solutions can be added to this cable if needed. But both the cables I've shown so far are PIA ready. We've gone through the testing. We can advise you on the clamps that we've used for our testing and things like that. We'll move on to our 5mm round OptiTap drop cable. Again, this has been through PIA approval. The beauty of this is it's compatible with standard tension clamps rather than the specialist clamps you need with flat cables, and also with it being a round cable, it offers far more flexibility during installation. The use of those standard tension clamps gives a more consistent tension performance as well. That's been proven that the round cables and the spiral clamps are far more consistent in their performance than the clamps that are used typically with flat drop cables. The way we supply this cable, it's suitable for a one-man installation, and it contains the stop position to avoid the connector being damaged during the installation. Again, with the OptiTap termination, we have other cables we can use, but this is the most common cable that we see used in the UK market with the OptiTap connector. The final drop cable, if you like, is our pre-ferrule blown fibre bundle. This is supplied on a cardboard ring as shown in the image. One end is fitted with a factory fitted connector, and the other end has a factory fitted ferrule. The ferrule can be blown through a duct, as little as 3.5mm ID duct, directly to the customer premise, and then you can build an LC connector around that ferrule at the customer termination point. So it's basically removing that need for splicing at the customer premise. The final area we need to cover is customer entry points. We got three slides to cover on this, so 3 products. We're going to start with the mini customer splice point. This product's compact size of 97 by 114.5 by 21 millimeters makes it one of the smallest termination points with positive fibre management throughout in the market. It has an IP rating of IP55. The thought that's been put into the design of this product is key. Whichever entry port you use to enter this box, it's managed directly to the splice tray. So the engineers in the field will instinctively route the fibers correctly to the splice tray. It really reduces the risk of an engineer routing the fiber in the wrong way and the risk of getting high attenuation or possible failures after installation. The box also fits directly to the Capin 25A. The box can house up to 2 splices on its hinge splice tray, and the splice tray can retain itself in 3 positions. The incoming cable would typically come from the underground duct, routed up behind the Capin into the bottom of the box. The exiting cable can exit through a port to the rear, which will allow direct entry into the house, or to the left or the right of the Capin. So it could go, for instance, in between 2 terraced houses, and you could take a drop out to each side, to the property to the left and the right. Also, if you've got a property and they want the cable, if the box is on the front and they want the cable to the side of the house, you can just use one of those ports and route that cable across the wall and in through the location where the customer prefers. Or you can go back down inside the Capin if you need to. Maybe there's some other ducting around the property that the customer would like you to use. It's obviously colour matched to the Capin 25A as well. We move to the CTP next, the customer termination point. This product's a bit bigger than the mini CSP, but it has the additional feature of fibre storage and adapters. So it has a large slack storage capacity, and its total capacity for a 3mm cable, for example, is 10 meters. The main benefit of this product over a lot of others is that we have these 2 storage mandrels. The benefit of these is you can store your network cable in one area and your customer cable, so the cable that's going inside the property, around another mandrel. So if you're unfortunate and need to go back and address a fault, then you don't have to take the whole lot out. You can just take out the section of cable where the fault is, replace it, cut it back, splice it, whatever you need to do. We also then have the 2 connector positions, so that's allowing up to 2 SC or 4 LC connectors. This box is also IP55. It's available in black, brown or grey. Moving on to the final product of the presentation, which is our HDB4. So this is like the mini CSP. It's designed to fit onto the standard Capin 25A. It also has the 2 connector positions. It also has the 2 connector positions as the CTP does, but it also has storage capacity like the CTP. So it fits in between the size of those 2 boxes in many ways. So here we can store up to 2 SC or 4 LC. The slack storage here is less, but for instance, if you're using a pre-ferrule blown fibre unit, we're still storing around 5 meters of excess length in this product. So it's still a good amount of slack storage. The splice tray can house up to 4 slices and can simply hinge away from the back of the box to allow access to the storage area and the connectors. The design itself is quite sleek. It's got these gentle curves, so it makes it quite easy on the eye. The cable entries and exits are very similar to the mini CSP, so it's the same sort of 2 ports that are inside the Capin, an option to go through the wall, and also an option to go to the left or the right of the box. IP55 rated as well, so fine for a wall-mounted solution. I'm going to wrap it up there. Thank you for taking the time to listen to us today. I hope you found it interesting. Please ask your questions and please contact us directly if you've got questions after today's presentation, and we're happy to share more information and details on our products with you. Thank you.
Thank you very much, Ian and Chris. That was great. Really, really interesting stuff. Much appreciated. So we move on to our question and answer session now. So without further ado, I shall start asking questions. So one question we have is, with the much thinner tubes you described in the presentation, is there a bigger risk of damaging the fibres when stripping them? And is the procedure different to stripping standard tubes? That's one for you, Ian, I think.
Yeah, good question. No, it's pretty much the same procedure, the same tools. So you still use the peg cutter. There is a little bit more emphasis on setting the blade correctly. So there is a little bit more care needed, but we do have a lot of training aids. We have some videos and stuff, and we'll also go out and help, train installers the first time. I think once you get used to them and once you've done a few, there's pretty much no difference in the way that you handle them.
Okay, perfect. Thank you very much. Another question about the fibres. Are the 180 micron fibres more brittle and easier to break due to the thinner coating? There's a concern they might be difficult to handle.
Yeah, I mean, again, it's a little bit like the tube, just getting used to them. It's similar to when we switched from 250 micron, now a lot of 200 is used. The first time you handle it, it feels a bit different. It feels a little bit more fragile, but again, it's just getting used to it. The fibre is quite robust. It'll handle in pretty much the same way. So it's really just, once you get the feeling for it, you have to be a little bit more delicate maybe, but it's pretty straightforward.
Okay, brilliant. Thank you. Someone's asked for overblowing. You said the distances are shorter than blowing a standard cable, but there aren't any typical values given to give an idea of how far it's possible to blow. Do you have any further information you can provide on that?
Yeah, it's a tricky question, because overblow, the difficulty with overblow is every situation is different. So every route is different. The legacy cable, situation is different. How many legacy cables are in the duct? Is it uphill? How many bends, etc.? So usually you would survey first. To give it's typically somewhere around between 200 and 500 meters are the sort of typical installations that we see. But there are things you can do to extend it as well, such as center blowing. So you can blow back and then blow forward as well at the same point, which can give you that additional distance if you need it.
Okay, fantastic. Thank you. And we've had a question about the 50-year testing. They want to know where they can get information about details of the tests carried out.
Yeah, I mean, we have a white paper, so if you leave your details in the on the platform, we can send that out. We don't tend to send it to competitors, just to sort of pre-warn people.
Thank you very much. We've got a question about the pre-connectorized closure now. Is it possible to fit a splitter in the field to the AC, DC and pre-connectorized closure? Is that, I think that's one for Chris.
Yeah, that's one for me. So in the AC, DC, that's quite straightforward. Yes, you can simply access the splitter area and clip your own splitter in. In the pre-co closure, it's a little bit more tricky. We'd probably need to know that was your intention, because there is one cover in there that's designed not to be easily removed. So we could try and make that cover sort of half installed, so you can remove it in the field to install your splitter. But yes, in theory, yes, in both cases.
Okay, brilliant. And again, someone's asked, when adding a drop to the pre-connectorized closure, do the other drops get affected?
No, they shouldn't. I mean, each cable's got its own entry within the multi-port gland. The seals are split, so you can slot them in from the side. You don't need to feed it through, and it shouldn't affect the way the other cables are anchored in the closure. So no, they should be totally fine, just fed through the same overall hole, but within their own entry within the port, so to speak.
Okay, brilliant. We've got a branding question now. Someone's asked if I wanted my own branding on the mini CSP, how would that work?
That's not a problem. It usually comes down to volume, if I'm totally honest. So for shorter, smaller volumes, we'd look at maybe adding a label to the cover. We've got labels that are designed to go sort of external on buildings. We just need some information on the logo to do that. If the volume's higher, we can actually look at moulding it into the cover. So that's obviously super permanent compared to a label. And we can do that. We need higher volumes. The lead time is obviously a bit longer to introduce that, because we need to get some modifications made to the tooling and things. But yeah, absolutely not a problem. It just depends whether we go down the label route or the sort of moulded into the part option.
Okay, brilliant. Someone's asked, the drop cables were shown on a cardboard ring. Can the cardboard ring fit to reusable bobbin that's compatible with cable dispenser 2A?
To me, I can answer that one. The quick answer is yes. There is various dispensing options or bobbins available to go on the 2A. We can tell you which ones they're compatible with and which ones they're not. But as with I mentioned, we could do different pull-in solutions and things like that. We can also look at, if you've got a specific bobbin you want to use, we can make sure that the packaging is developed and compatible for that. So we've got the flexibility to do that and manage it to ensure that it's going to work.
Okay, fantastic. Thank you, guys. So that's the last of the questions, which brings us to the end of today's webcast. Just to let you all know that the webcast will remain on demand on the Fibre Systems website, which is www.fibre-systems.com, for the next 12 months. Although the live Q&A obviously won't work if you're watching it on catch up. So just to bear that in mind. So I'd like to thank very much Ian and Chris once again. Thank you so much for joining us and for talking to everybody today and for answering our questions for everybody. I'd like to thank our sponsor Prysmian, of course, the Europa Science production team working in the background on the platform to help this happen. And I'd like to thank everyone out there that's taken time to watch today. Thank you very much. Bye-bye.
Thanks, everyone. Bye.